Hello to everyone, my name is Damián Pérez and I'm going to show you the work done for European project Durable by the University of Seville so far. In this video I'm going to show you the trajectory generation that our system has, and to command the multi-UAV formation I will use the developed operator interface that will let us interact with the formation through high-level commands. A preloaded configuration file is implemented in order to speed up the process of setup. We demanded several waypoints to be able to trace trajectories, and we also indicated an initial inspection distance, formation angle, flying mode, among many others. First of all, we have to take off the UAVs, and once they are all flying, we will start the mission. Once this is all done, the formation will start to reach the waypoints that the operator has indicated in the same order that were imputed. For instance, we can now operate the joystick simulator as it is the main tool that the operator would use in this case. We can either increment or decrement the reference of the inspection distance and the formation angle during the flight. And in addition, we can see at any moment the current formation angle and inspection distance, as well as the errors that each UAV has. Let's increase, for instance, the inspection distance by pressing the W key. And here you can see that the formation is gradually approaching the new inspection distance, as the formulation that we have implemented is thought to have a smooth flight. The formation should be flying around a cylinder that represents where the formation has to fly, as it has to keep a constant inspection distance, and when the waypoint is reached, the formation trajectories will be attached to the cylinder. You may have noticed that the UAVs are flying quicker now, and this is because the formation is thought to last a certain amount of time to describe a complete cycle around the structure, so regardless of the inspection distance value, the cruising speed is adaptive in order to achieve the indicated time. The reason why we are using cruising speed is in order to have a pleasant flight and avoid varying the accelerations, even though we have an optimizer for the trajectories that minimizes it. We can also operate the formation angle that, in this case, I will decrease its value by pressing the AK key. And as you can see, they quickly move to the new reference of formation angle, and I will quit the joystick simulator now to show you other options that the operator interface has. And now it would be interesting to show you the flight modes. This application has 4 flight modes so far, that are the non-stopping mode, that will make the formation never stops as long as there are waypoints yet to reach. The smooth flight mode, which will keep the formation flying as long as there is no change of direction because of the waypoint's positions. The stopping mode, that makes the formation always slow down while they are reaching a waypoint. And lastly, the inspection mode, that will make the formation completely stop in the waypoint, having the possibility of operating with the joystick simulator. So by default the flight mode is non-stopping, but let's check the inspect mode for being the most useful. And right? All right. So as you can see, the inspection operation will start when the leader UAV reaches the next waypoint that is on the list. And now we can open the joystick simulator that I have already done in order to move the formation from that perspective, being able to operate with the inspection distance and the formation angle. Let's have a closer look of the structure by reducing the desired inspection distance. Currently, the formation has a cruising speed of 0.2 meters per second for inspecting purposes, but we can modify its value in the configuration file. And now we will spread the follower UAV's position by increasing the formation angle value. And to conclude with this tool, let's have a change of reference of both parameters at the same time. It is quite important to mention that there is a safe corridor generator implemented in our formation that so far we achieved to avoid them knowing its position previously. In this scenario, it is not suitable to develop tests, so let's change the world quickly. This is a simple scenario where we have tested our safe corridor generator, and we are going to show you a simple video where the obstacle avoidance is done. In this case, the procedure is the same. We have to take off the UAVs and start the mission. In the auto configuration file, we have added several waypoints that will make the formation fly several times in the clockwise direction around the inspection point that in this case is the gazebo world frame, which corresponds to the 000. There is an important thing to mention here, and this that at this point of the project we are doing the obstacle avoidance with static and known obstacles, so we can't add the information of the obstacles within a PCD file. So let's make the formation fly and see how it avoids the columns that interfere with their trajectories. We can see that each UAV tries to avoid every obstacle that they find in their way, adding also a distance with them just in case. When the reference trajectory that is generated comes across with an obstacle, a new path is computed to avoid the obstacle by using the jump point search algorithm, or JPS, which consists of an optimization of the A-star algorithm. The objective here is to know dynamically and in real time where the obstacles are located, even those whom we do not expect. For that, a lidar sensor will be added to each UAV of the formation, and we will translate the information that the lidar offers to a node that transforms it to the frame where we are working on, and refresh the point cloud that depicts the obstacles at a certain rate.